Welcome. I'm Dr. Owen Anderson, and today we're going to look at science, religion, and philosophy. I'm a professor of philosophy and religious studies at Arizona State University, and I teach and publish in the philosophy of science. Today's lecture is titled Charles Lyell and Uniformitarianism. That's kind of a big word, and it's not a very common word. So we're going to look and see what on earth is that? That's part of what we'll be studying. So when we do something like the philosophy of science, it can often seem that we're distancing our studies from actual science that occurs. And we're not really teaching the students what science is, processes in the lab, hypothesis, examination, verification. Instead, we're doing something that's a whole different project. And so I want to sort of address that in this talk today, because I think what I want to suggest is that when we're doing philosophy of science, we're teaching things that are essential to finding meaning in the scientific project. So I believe that first kind of thing happens because the philosophy of science can turn into a kind of speculation about future possible scientific theories. Maybe get into things that we now think are science fiction, and thinking about how they could work. And in 20 years, 30 years, what we thought was science fiction now is real. And so that can then begin, because a lot of it turns out not to be real. So some of the things we thought would happen don't happen. Still aren't hoverboards, or at least not useful ones that we can all ride to school on like we'd hoped. So that's one kind of philosophy of science. I'm going to suggest we learn something a little bit differently. And I'm going to discuss the philosophy of science as studying the necessary conditions for science. What must be true about ourselves and reality for the scientific enterprise to be successful? I'm going to use this Google Doc, and I have some notes I'll go through, but I also have an article I published in the journal Zygon, which I'll toggle over to. And then I also have some quotes from Darwin, which I'll toggle to as well. So for now, we'll continue here. And I made the text kind of extra big, larger than I would usually have it. So I hope that helps as we're reading it. And I'll try not to scroll super fast because I know that can be disorienting. But I put this up there so you follow along. So we have both a lecture and then these notes, and then hopefully you'll be able to engage with those, and we'll have some question and answer time. So we can discuss differences that come up. And here's the first point. We can discuss the study of the laws of nature as science, right? Science is studying the laws of nature. What are they? How do they operate? That's different from the study of the origin of those laws. Where did those laws come from? Where did anything come from? It's the latter study that is a question of, is it science, religion, or philosophy? That's the first point. The origin, the study of origins, is that science, religion, or philosophy? And it's very common. You might see an article once a week, once a month. Scientists discovered the particle, the God particle, or the new theory that explains the origin of everything. An ASU professor became somewhat well known for publishing a book, A Universe from Nothing, absolutely nothing. And that's not to be confused with creation ex nihilo. He wasn't arguing God made the world from nothing, which is an argument about how God alone is eternal and the world came into existence. No. He means not even God. Nothing was there. So that's a scientist doing origin work. And he was projecting back what is currently observed and saying, if what we're currently observed has always been happening, then here's what it would look like into the past. And that's what I want you to zero in on right now. Put a pin on that in your mind. Assuming that what we now observe has always been happening. So this first question, is the study of origins a study for science, empirical science, religion, or philosophy? Now, science is the evidential study, the empirical study of what we now observe. So in science, you need to be able to test things in a laboratory now. And that means if there are some things that happened in the distant past, you're only able to test in the laboratory insofar as the present is like the past in a relevant way, and it may not have been. So for the scientific empirical sciences to work, you have to be able to make a hypothesis, test it in the lab, and other scientists can do that same test around the world, and you can confirm each other's research. So that's science, and that's the study of the laws of nature. Now, religion, I'm thinking here especially of revealed religion, not natural religion. Religion is assumes God, right? The revealed scriptures assume that God, the creator, is real and created the world. For example, Genesis just starts there. Right? In the beginning, God created the heavens and the earth, and here's what he did next. It's not a philosophical work giving you kind of a prolegomena or prelude or introduction to, well, how do we know God is real, right? That's different than what Genesis does. That's not to say it's true or not true. That's just to say it begins there. So empirical science assumes empirical science assumes that we can use our senses to test the world now. Revealed religions assume God, the creator. Now, philosophy is different than both of those. Philosophy, sort of following the model of Socrates, is a critical examination of assumptions. Neither one of these does this. Science and the empirical sciences assume knowledge from the senses as possible. They don't prove that. Day one of physics class is not a proof of the existence of the material world. It assumes the existence of the material world. And similarly, if you get into biblical theology class, you wouldn't, in that kind of class, there might be other classes that do what I'm about to mention, but in a biblical theology class, you just start with the Bible. But philosophy examines assumptions. Let me put that here. Philosophy is the only one that examines assumptions and tests them for meaning. Science doesn't do that. Religion doesn't do that. So the study of origins is a philosophical study. When this scientist I mentioned was talking about how the universe came from nothing, he was engaging in philosophy, even though he was trained as an empirical scientist. And what's interesting, which he may or may not have known, didn't indicate that he knew it, is what he was saying was just what Lucretius had said earlier. He just believed that atoms and the void exists. And once there was just the void, now there's the atoms and the void. So it had already been said. If you knew the history of philosophy, you'd know, well, my theory is a recycling of other materialists, and I'm a materialist. But that's what I was looking at earlier, right? Remember, what must be true about ourselves and reality for the scientific enterprise to be successful? Could science be successful if only atoms and the void exist, which would mean we're just made up of atoms and the void? That's part of the question we're asking. And that person coming at it as a scientist or as a materialist is then giving us, not surprisingly, a materialist origin of the universe. Or one of, I think it might have been Stephen Hawking's last book, The Grand Design, in which he talks about a universe from nothing also. Because there's a law like gravity, he says, quoting, we can get a universe from nothing. So attraction, again, that's just the Greek materialists, the law of attraction, which they might have called eros, and the atoms are attracted to each other. Different atoms are attracted to different atoms. So materialist philosophers end up recycling some of the same ideas in contemporary language. If they had known, though, history thought they would see that. And when they do that, they're getting into philosophy. They're doing philosophy, and they're suggesting that we also should be materialists in our understanding of reality. And that's part of what we're doing then in philosophy, is we are questioning that. We're learning to examine assumptions. Let me add in here. Think critically. Critical thinking is a very common phrase, right, in education. We want our students to think critically, although it's not always meant, when it's used, I don't find that people always mean the same thing by it. So we have to say, well, here's what it is. When you think critically, you examine the assumptions of yourself or others and test them for meaning. And again, I think I in my classes, I use the trial of Socrates in the Apology as an example of that. He wants to think critically about the claim that he is the wisest by seeing if other people are more wise than he is. And he comes to find that they think they know, but they don't know. whereas he at least knows when he doesn't know. So that's just a quick overview of critical thinking as exemplified by Socrates. All right, so that's the first point. The study of origins is a philosophical study necessarily, even when scientists, renowned scientists, top of the field, top of their game scientists engage in origin talk, they're doing philosophy, and they'll end up saying some of the same things philosophers have already said. They'll get into, say, like I said, Lucretius and the atomic atoms in the void theory. All right, so second point. How should we understand change? And to bring this up, I'm going to use uniformitarianism to highlight how first principles work. How should we understand change in Earth's history? And this is something called uniformitarianism. And that's the belief. Let me scroll down real quick to Charles Lyell's definition of it, and I'll scroll back up. He articulated the principle in the following manner. Uniformity meant one uninterrupted succession of physical events governed by the laws now in operation. One uninterrupted succession of physical events governed by the laws now in operation. Uniformitarianism, right? So uniformity, and if you're a follower of it, you add on the ism, right? Uniformitarianism, the movement. And so in other words, when you look and you say to yourself, how was the Grand Canyon formed? Any geological structure, how are strata in rock formed? Maybe the wood planks behind me kind of illustrate geological strata. And how are they laid out? How are the mountains formed? How is the Grand Canyon formed? Well, what Charles Lyell says is this: you should use forces now operating, say the current amount of erosion from rain, the current amount of continental drift, project that backwards to give an explanation. And what you end up getting, of course, are great ages required. The current amount of erosion in the Grand Canyon, well, that would take millions of years. Yes. So uniformitarianism is used to then say there must have been this great amount of time in Earth's history to give us what we currently see, because all we can rely upon are current forces. So how should we understand change? The alternative is called catastrophism. Which says that there have been great catastrophic changes in Earth's history that would alter the appearance and interfere with dating methods. Oh, interference, yeah. Interfere with dating methods. So I'll explain that here a little more. So catastrophism and uniformitarianism. And this debate, I don't know that any students today are even taught about, unless it's in like a history of ideas class. But no science student is alerted to these, unless it's maybe a side note. And I can say that so I did physics, I did geology as an undergraduate, both of those sciences, and it wasn't brought to my attention. So that's considered settled. But is it settled science, or is it an agreed upon philosophy? And what I'm pointing out is it's not a settled science, it's an agreed upon philosophy. So the first point is are origins a matter of science, religion, or philosophy? Second point is the assertion that we should use uniformitarianism to understand Earth's history. And so the third point is this: what best fits the geological data? And so now you're into a kind of science question. Right now, you're going to look at the data, the empirical evidence, and say, does it give us signs of uniform past or of a catastrophic past? And how would that affect other things like carbon-14 dating? You might know about this, looking at the amount of carbon-14 in a bone, what used to be a living creature, how much is in there now? And since we know the half-life, the current half-life of carbon-14, and we know how much carbon-14 animals currently absorb, adding those together, you can get the time since this creature died. Now, there's two assumptions there already, that the half-life has stayed steady in time. What if that changed? Well, then that would throw off the whole mechanism. It'd be as if you have a wristwatch which goes at different paces. It randomly sometimes goes faster, sometimes goes slower. Well, it would be terrible at telling the time. So that's what would happen to carbon-14. So carbon-14 only works if uniformitarianism is true. And the same with uranium dating, which can go back supposedly further. Radioactive dating can go back even further. Same assumption. So the carbon-14 assumptions were that the half-life has been constant and that living creatures in the past absorbed carbon-14 in the same rate they absorb it today. What if they absorbed more in the past or less? Then that would throw off the dating. So this is dating methods. And that's one thing we can tell our students, hey, today we're going to study dating methods. And they'll think, whoa, this is all right. This is great. Well, a different sense of dating methods. How old is the Earth? Notice how these different first principles would come up with different answers to that, and not for religious reasons. In fact, I should tell you that the great majority of the world's ancient religions believed the Earth was very old. Some of them might have said humans haven't been around that long. Aristotle gave some arguments of why he thought humans hadn't been around that long. But the Earth itself, Aristotle said, was eternal. How old is that, right? It had existed with no beginning from eternity. And that's the same for Hinduism. Great millions and millions of year-long ages in which Brahman awakes and then goes to sleep, and this cycle continues for millions of years. So the vast majority of these religions said the Earth has existed from eternity or is incredibly old. So that's not a modern scientific debate. I know we think about that. That's a 20th century debate between religious people who don't know science and scientists. No, the religious people, if we were to somehow take a poll of religious people in the history of the world, most of them fall on the side of saying the Earth is incredibly old with the 20th century uniformitarians. So we don't want to let this become a battle of science and religion. It isn't. It's two competing philosophies that we want to teach our students about and how to think critically about. The materialists have always said the Earth is eternal and very, very old. And it's probably really only those groups influenced by Genesis that have said otherwise, that God made the world not that long ago and made it with a purpose, and humans were there from the very beginning, right close to the beginning, right? Day 6 out of, not day 1, but day 6. And there are reasons for that. We're going to actually look at some of them in a little bit, but those are not, the debate we're having is not then science and religion. It's two different philosophies. So keep that in mind. And we're in this third point now. The first was science, religion, or philosophy. Second was about uniformitarianism and catastrophism. And third is just doing the scientific work. Which of those best fits the geological data? And so you can consider some of that data. Fossil beds. Are those best understood as being slowly developed? I mean, you have sometimes great creatures fossilized, and if they're slowly being buried, their bodies would have rot and you wouldn't have a fossil. So do fossil beds indicate a catastrophic event happening that covers them with great pressure? Coal beds, similar plant, almost like plant fossils. How about the sedimentary strata, which are kind of, like I said, these planks. They're relatively flat in having been laid down. Does that indicate a slow laying down over time through erosion, or a quick laying down so that the levels are preserved? Mountain ranges and uplift of mountain ranges, again, dramatic or slow. Volcanic plateaus, how were these formed slowly over time or rapidly through volcanic activity? Interestingly, this is another debate that was occurring about the same time as uniformitarianism and catastrophism, is the Neptunists versus the Vulcanists. Right, so those guys both said that they could fit into maybe either one of those, but they could fit into catastrophism, saying the world was formed through some very dramatic, catastrophic events. But they disagreed on this: were those water events, the Neptunists, or were those volcanic events, the volcanists? And so people agree, right? One, not say tiny, but one small volcano like Mount St. Helens is not a huge one, but think of how much Earth was moved in that explosion. Imagine if there were lots of volcanoes going off at once. Is that uniform or is that a dramatic change? Ocean depths, how could those have occurred? And then meteorological changes of the kind that, say, for example, flash freeze the woolly mammoth, so that when they're thawed today, they still have cud in their mouth. So we can look at those and say, which side do they indicate? What is the evidence, doing sort of empirical science, testing hypothesis, indicate? Now, what's interesting is you'll actually hear scientists today being uniformitarian, but giving us catastrophic explanations, perhaps not seeing how that would throw off their dating methods. If I was to ask you, what is the common solution to the extinction of the dinosaurs? Yeah, a meteorite slams into what is now the Gulf of Mexico, creates what would be a global tidal wave from that, and alters the entire weather conditions of the Earth, meteorological conditions of the Earth, and the dinosaurs go extinct. Well, wait, that sounds like a global water event. It's just a global water event without Noah, but it's a global water event which would have changed the whole surface of the Earth. So that's catastrophic, and that would then put a dent in these dating methods. So first principles, philosophy or science versus religion or philosophy. And I'm trying to see this how we can break the logjam, break the debate between science and philosophy by saying, no, wait, both of you guys have assumptions. Now let's look a little bit at my article in Zygon to illustrate these points. I have the link here for you, my webpage, drowenanderson.com. If anything, if you just went there, you'd see my online library link. You could click it and find this. So I'm gonna read a couple things. I might toggle over to it as well to give you a few more, but I put some of the quotes here so you could have them. And this is me speaking in the article. We have seen that during the progress of geology, there have been great fluctuations of opinion respecting the nature of the causes to which all former changes of the Earth's surface are referable. So just that first point, there's been great debate about how did the surface of the Earth change? The first observers conceived that the monuments, which the geologist endeavors to decipher, relate to a period when the physical constitution of the Earth differed entirely from the present, and that, even after the creation of living beings, there have been causes in action, distinct in kind or degree from those now forming part of the economy of nature. These views have been gradually modified, and some of them entirely abandoned in proportion as observations have been multiplied and signs of former mutations more skillfully interpreted. Many appearances, which for a long time were regarded as indicating mysterious and extraordinary agency, are finally recognized as a necessary result of the laws now governing the material world. Right? That's the uniformitarianism. Though all of Earth's history is governed by the current laws. Now, that doesn't mean, for example, like the laws of gravity, like in the past, gravity was greater, although, all right, we could put that aside, maybe not. Speed of light could be debated now. There's actually been suggestions that some things can go faster than the speed of light. So secondary questions we're not going to look at right now, but it's more like the current observable forces, rain, erosion, continental drift, those types of forces, if they were greater in the past, let's say they're going into millimeter a year, then you can project back based on that if it's a millimeter every year. But what if it was a centimeter some years and half a millimeter other years? Well, you'd have to say, well, I know what the average is, and we don't. So the discovery of this unlooked for conformity has induced some geologists to infer that there has never been any interruption to the same uniform order of physical events. That's the uniformitarianism. The same assemblage of general causes they conceive may have been sufficient to produce by their various combinations the endless diversity of effects of which the shell of the Earth has preserved the memorials. Now that, I think I said that was me. That's Lyell. Let me toggle over here. Oh, sorry if I just scroll quickly here. I don't want to I'll go to the top of the article for us. There he is. Charles Lyell, Uniformitarianism. And I have a link here, also active link to Zygon. Boy, I did this one in 2007. That's geological ages ago, isn't it? Yeah. So here's a quote from him. I said that was me. That's not. That's him. Starting there. Good. Now, so that's where he lays out. I just want to give you a sense. And he's recognizing there's been some debate, but we've finally come to realize that uniformitarianism is the truth. And what we'll see is not so much finally coming to realize that, but just asserting it and people agreeing on it, which is not the same as having proven it. So I quoted this earlier, that he articulates the principle in the following manner, that uniformity meant one uninterrupted succession of physical events governed by the laws now in operation. So what does this mean about Lyell? Teaching our students and for ourselves to think critically about science and scientists means identifying their assumptions. And so I do that here about Lyell and how those assumptions shape his understanding of the world. First, he was an actualist. He wanted to explain past geological phenomena in terms of causes of the kind that are operating at the present. Again, that's a philosophical belief, not a discovery of science. Second, he was a uniformitarian. He wanted to explain only in terms of causes of the degree operating at the present. That is, he wanted to avoid catastrophes that would then alter the age of the earth. So only present causes operating, and they've always been uniform. And then third, as a geologist, he saw the earth as being in a steady state in which all periods are essentially similar to one another. Now, again, just like the fellow I mentioned earlier who did the all is atoms in the void, these three things are philosophical assertions, not scientific. But think of how many people have come down to the present and then maybe have engaged in the debate between science and religion, thinking that they're on the side of science because they hold to these things. Instead of saying, no, you're on the side of certain philosophical assertions against what you call religion, which has other assumptions. Now, what are some motivations for this? Because you might think I'm painting this only negatively. Lyell was saying that the use of observable forces to explain origins is better than the use of catastrophes, or what he considered to be overextended supernaturalism. So you can think about this, and I think this is the view that the science and religion debate gives of religion, which is what it really means is supernaturalism, superstition. I'm going to add that one in there. Let me add this in here. I'll say it called this way: overextended supernaturalism. Everything is referred to, every cause ends up being something supernatural. It might be God, but that could also be angels and demons or spirits, mana, power. So that's the view. Now, overextended supernaturalism is consistent, could be consistent with a great age of the earth. Like I said, most of the world's religions have said that. That's been the denial of God, the creator, has always been in saying the earth is eternal or it's very, very old. God did not make things as we see them. So I think we can relate to that. Overextended supernaturalism, which can hinder empirical science. It's not given to repeatability and verification. And underneath that, the force of overextended supernaturalism, humanity didn't make a lot of progress in understanding the natural world. And when that was removed, it was like a mushroom of growth in understanding the natural world. So you can understand that, and you can understand not wanting to return to that. Sometimes nowadays people will read Charles Taylor and they'll want to what's the word? Spacey now, isn't it? Re-illuminate. The world is disenchanted. They want to re-enchant the world by going back to a time when we believed in these kinds of spirits and things like that. And then you can put him up against Steven Pinker. I think his book is titled Enlightenment Now. And he's saying, whoa, wait a minute, look at all the progress that we've made. You'd be giving up all that progress if you went back to this pre-modern worldview of overextended supernaturalism. And you can see Steven Pinker's point. I mean, you think about what just happened with vaccines, right? Because we understand virus and germ theory. We understand the immune system. We didn't have to do some supernatural thing, right? We very quickly, with under a year, under 6 months, came up with a vaccine for a major pandemic. In contrast that with the bubonic plague and how long that ruled. So Lyell has understandable concerns. The materialist philosophers have understandable concerns. But in avoiding overextended supernaturalism, do they overextend the other way to overextended materialism? And the overextended part is in this, because when you're studying the laws of nature, you are studying natural laws, material laws of matter. But then the overextension is in when you extend those into the origin of the laws. You can't use the laws themselves to explain their own origin. And I quoted that to you earlier from Hawking when he said, gravity explains the universe, which is where gravity is. So now you have overextended materialism. And it's that first point I had. It's the problem from the very beginning of our talk. Using science not to study the laws of nature, but to study the origins of those laws. So a little more here about Lyell. Lyell makes force absolute, the observable forces around us now, and he's willing to alter time as needed. So think about that, how relativity works, right? If you said time is short, but force is great, like a worldwide flood, like the extinction of dinosaurs, that happened very quickly, not over millions of years. A meteorite smashes into the Gulf of Mexico and they're gone. Or you could say the force is low, like the current erosion of the Grand Canyon. Therefore, time must be great and take millions of years to get the Grand Canyon. So he's going with the side of force. He's saying force is absolute. We have to make time greater. So it's possible to alter time and force as needed to your theory. The uniformitarian appeals to great amounts of time and limited forces now observable. And this seems to be more scientific than the alternative because you're talking about what's observable. But if the uniformitarian wishes to make force absolute, why can't the catastrophist make time absolute? So it's not more observable, or sorry, more scientific to say, because I observe these now, I can project them into the past indefinitely. Well, that's not more scientific, that you weren't there observing in the past. So does the geological record show evidence of a steady state or catastrophic changes? That's a good scientific study once we've equipped our students with the ability to think critically about this. Now, here's the big one, and it comes out in my article. So if you want to follow this up, read my article. I spend more time on it. The problem of evil, which is affecting both Lyell and then Darwin, who relies heavily on Lyell. And the problem of evil just says this: where did evil come from? Was the world originally good, or have there always been natural evils like old age, sickness, and death? Think about that. The process described by Darwin requires that there's always been old age, sickness, and death. You can't have survival of the fittest without the struggle to survive. And yet, in the Genesis account, we're told that the world was made very good. There was not yet old age, sickness, and death. Those come into the account after sin. Now we have two very different views of origins, which are not resolvable through laboratory tests. Like you get two vials to test. Was there always natural evil? Yes, there was always natural. No, that's not how it works, right? These are completely different worldviews operating. And again, our students may not be aware of that at all. They might just think, no, of course there was always old age, sickness, and death. Well, why should we think that? Let me give an example from Darwin. And I have this is from Origin of Species, and I have a link posted below to these quotes. The influence of the principle of uniformity cannot be overestimated. Darwin's relying on Lyell. If Lyell is wrong about uniformitarianism, Darwinism is not true. But such influence means that the theories based on this principle are only as good as the principle itself. See, that's what I should say. He gets that too. If it turns out that the principle is imposed to hold consistently, it is impossible to hold that only the empirical can be appealed to as an explanation. The scientific theories that use it as their foundation are in trouble. Given the centuries of work based on Aristotelian interpretive principles that are so easily dismissed now, it should not be out of question that the past 200 years have been based on an equally incorrect interpretive principle and in need of correction. And I apologize. This is me. I'm going to take this off here. I don't know how Darwin got there. He's next, but this is me. No wonder when I said it and it sounded so similar to me. So the principle of uniformity cannot be overestimated on Darwin. And people are willing to see how the influence of Aristotelian philosophy may have kept science back. So we should be equally open to say, you know what? This also could be an incorrect interpretive principle. And that's part of critical thinking about science. It actually promotes science, because what could be done under the name of science will then turn out not to be science. It'll just turn out to be materialist philosophy. We could think, oh, I dodged a bullet. I'm not doing religion. But you're not doing science either. You're just doing materialist philosophy, Lucretius, atoms, and the void. Let's learn how to do actual science. Now, let me quote. This is Darwin. Authors of the highest eminence seem to be fully satisfied with the view that each species has been independently created. To my mind, it accords better with what we know of the laws impressed on matter by the Creator. Think about that, what he just said. That is not a scientific statement. In his opinion, his theory fits better with the idea of a creator. Oh, well, great, good for you, but that doesn't mean it's true. And that's not a scientific proof. So to my mind, it accords better with what we know of the laws impressed on matter by the Creator, that the production and extinction of the best of the past and present inhabitants of the world should have been due to secondary causes, like those determining the birth and death of the individual. Old age, sickness, and death have been there from the beginning. When I view all beings not as special creations, not created by God, each after their own kind, he's directly rejecting that, but as the lineal descendants of some few beings which lived long ago before the first bed of the Cambrian system was deposited, they seem to me to become ennobled. Again, not a scientific proof. It seems my view seems more sublime than the alternative. Well, that doesn't mean it's true. Judging from the past, we may safely infer that not one living species will transmit its unaltered likeness to a distant futurity. And of the species now living, very few will transmit progeny of any kind to a far distant futurity. For the manner in which all organic beings are grouped shows that the greater number of species in each genus and all the species in many genera have left no descendants, but have become utterly extinct. We can so far take a prophetic glance into futurity as to foretell that it will be the common and widely spread species belonging to the larger and dominant groups within each class, which will ultimately prevail and procreate new and dominant species. As all the living forms of life are the lineal descendants of those which lived long before the Cambrian epoch, we may feel certain that the ordinary succession by generation has never once been broken. I was building up to this point in the quote. This lineal progression, succession by generation has never been broken, and no cataclysm has decimated the whole world. Now, what cataclysm does he have in mind? Because now the scientists say there was a cataclysm with that meteorite striking the earth. But that's the theory now. That was not back then. He's referring, of course, to the biblical flood. So he's rejecting each after its own kind very directly, and he's rejecting that there was ever a cataclysmic event that would have reshaped the entire surface of the earth. So he's aware of that. When we get into debates about it, it's not Darwin versus Genesis, even though he's directly saying Genesis is incorrect. Well, what it is Darwin's proposing his own philosophical principles by which to interpret the origin of species. He draws an analogy. We can currently breed dogs to get the kinds of characteristics we want. Given enough time, nature could do the same thing relatively blindly or guided by natural selection. And since we have had enough time, that's what must have happened. Whoa. How do we know we had enough time? Because of the geological age of the earth. Well, how do we know the geological age is old? Because of uniformitarianism. Well, how do we know that's true? Because of all the time that it would have taken. That's the best theory that explains it. And you've got it. Now you've got a circle going. Sometimes it comes down to this, and this is, I've really been told this, so this is not a straw man. How do we know this bone is old? Well, it was found in an old layer of dirt. Well, how do we know the layer of dirt is old? Well, we found an old bone in it. So that's how it works. I'm just direct circles. That's not what we want to teach our students. We want to teach them how to think critically about philosophical assumptions. So our science education includes education about first principles. We can teach our students to identify these and to think critically about them as part of the growth process. And what this does, I think, far from scientific education, it increases science by not allowing what really is just philosophical materialism to pass as science, but to preserve and encourage the actual study of the laws of the world and distinguish that from the origins of those laws. And this brings out the great importance in the study of natural laws and their origins. And I think in doing this, it fills them with meaning and wonder, increases our love of science. Thanks for joining me today.